Alright, let us look at this another example. B is on a bearing of 50 degrees from A, and while C is on a bearing of 150 degrees from B. So here we have two set of bearings. Okay, let us move to the question. Represent the information on a diagram. Alright, so what we need to do is to represent the information on a diagram. I'll go back to this. I'll just leave this at the side so it can help us with our diagram. Good, so the first thing I'll need is my north line. Good, so I have my north line here. B is in a bearing of 50 degrees from A. So 45 is there, 50 should be, okay, so I know that this is 90, 45 is somewhere there. Well, let's say 50 is there. So here's A, here will be B, good. So we start from the north line in a clockwise direction. Going that way will be anti-clockwise. Good, so we have 0, 50 degrees, that's our bearing. What else we know? While C is on a bearing of 150 degrees from B. C is on a bearing of 150 degrees from B. So since we are starting at B, whenever we are starting at a point, we need a north line. So since we are starting there, I put the north line. Good. So what we need to represent, 150 degrees. 135 is there, 150 should be somewhere within that range. Good. I know if I go straight down it's 180, so 150. And you should always look at this as well. The distance AB is 25 meters, right? So this distance here is 25. Let me write it out there. I can write it below here. 25 meters, right? And if you look at this, the distance BC is 34 meter. So what needs to happen? The line BC, the length of this line should be longer than this one. Since this is 25 meter, and we want to represent 34 meter, the line should not be smaller than this. It should be long, right? You don't have to be exact. You don't have to draw to scale. So let's say that. Good. So this, if you look at it clearly, this line is longer than that. And here's my point C. Here's the bearing from the north line going that way, 150 degrees. This distance is 34 meter. Here is the point C. Good, so that completes our diagram. Represent the information on a diagram. Good, so we are good with that. Part B. So here is part A. Now let us move on to part B. Part B says now what? Calculate the distance AC. So we know the length of AB, we know the length of BC, we don't know the length of AC. So what I'll do, I'll connect AC. We can use our broken line. Use broken line to connect it because it's not really a part of the diagram. But since we want to find this distance, use the broken line to connect it. Good. So if you look at this, we have a non-right angle triangle. Let us try to find this angle. If we find this angle, since this angle will be within these two sides, we can use cosine rule to find here. In order to find this angle, what we need to do is to project this north line. When we project that north line now, from the first set of examples, we'll understand that between two north line, alternate or z angles form. So this angle here, this 50 will equals to, so from here to here will be 50 degrees. Good. So that from this distance to that distance will be 50 degrees, but this part is missing. We also know that this is a north line and is a straight line as well, so it's made up of 180 degrees. So since from here to here is 150, 30 will complete the 180, so here will be 30 degrees. Good. So in total now, from here to here is 50, from here to here is 30. So 50 plus 30 will give us how much? 80. So this will be 80 degrees. Good, so we put the 80 outside, so we show that here is 50, here is 30. Good. What I'll do, I'll remove this triangle, draw it back, and then we'll find the distance AC. So let me draw back the triangle. It's not exactly the same, but it's just, you don't have to get it the exact drawing. Here's 80 degrees, here's 25 meters, 34 meters. Good, so we know with non-right angle triangle, we label the opposite side in common letter. So opposite A will be common A, B, C. Okay, since I teach this before, I'll go through it quickly. So since we want to find for AC, which is also known as B, we'll use the B formula. So I'll write, what's the B formula again? B square equals to A square plus C square minus 2AC cos B. No, you probably memorize it by now. So A is 34, so I put 34 square plus C, which is 25 square, minus 2 times A, which is 34, times 25 times it by cos 80. Good, so now our calculator will do the job for us. We can enter all of that at once on a calculator, so let me try that quickly. 34 square plus 25 square minus 2 times 34 times 25 times cos 80. What do we have? It's good to write this part here to 3 decimal places. So I'll write the answer to 3 decimal places. I have 1485.798, and you don't remove the answer in the calculator. Leave the answer in the calculator, and all we need to do now, okay, so our next step, so we know that B square is equals to all of this. We don't want to find B square, so we want to find B. We'll take the square across, we'll square root this. 1485.798. We find a square root, so we leave our answer in the calculator. So now we'll square root the answer. This is a square root function. We square root, what do we have? 38.5. Let us write it to 1 decimal place. 38.5. So our answer will be 38.5. That's what, meter? Yeah, meters. And let me just state in bracket correct to 1 dp. Meaning that that's not the exact answer, we just round it off to 1 decimal place. Good, so we are good there with part B. Let us now do part C here. Okay, part C. Determine the bearing of C from A. The bearing of C from A. So we need to see which line connects C and A. So let us look at the diagram. Which line connects C and A? That's this line here. This line connects A and C, right? Or C and A. Good. So we want to determine the bearing of C from A. From A, the bearing of C, we want to determine the bearing of C from A. So we start in at point A and we need to go to point C. So we start in here and we need to go to this line. Why we need to go to this line? Because this line here connects point A and C, right? So determine the bearing of C from A. So from A meaning that we are starting at point A. Let's say if this question was determine the bearing of A from C. From C, we'll have to draw a north line at C and then have to get this bearing instead. Right? So we need to find this bearing. I know from here to here, it's 50 degrees. Now I need to know from here to here, and then I need to add that to the 50 to get the entire bearing. So what I'll need to do now is to find this angle. So let me quickly draw a triangle. Alright. The triangle is a little different from that, but doesn't matter. A, B, C is 25, 34, and we just found here to be 38.5 meters. A, here's C, B. We know that here it's how much? 80 degrees. Alright, there are two ways we can go about. We need to find for this angle, because we want to know this bearing. So if you find for this angle here, we can add it to the 50 to know the entire bearing. And this here is a typical CXC question. So you'll find questions like this coming in the exam, just in case if it comes. Good, so I need to find for this angle. We can either use a cosine rule or a sine rule, right? Let's say if you want to use a sine rule, that will be, so since we want to find for this angle A, and we can use sine B, sine A, sine B in order to find for this angle. And since we know all three is the length of all three sides, we can use a cosine rule. Cos A equals, we can use that formula. Alright, I'll use the sine formula here, sine rule. So I'll write sine A, A over sine A equals to B over sine B. Good, so A is 34, so we have 34 over sine A. Well, we don't know angle A is yet, equals to 38.5 over sine 80. Good, so now we'll cross multiply. Alright, so since I want to find for sine A, I'll write that over the right hand side. So I write sine A times 38.5 equals to 34 times sine 80. So since I want to find for angle A, let me take this across. Is multiplying here, when it goes across, it divide, right? And then I need to find for angle A. So what I'll do, I'll take the sine as well across. So it will be sine inverse. So what I'll do here, I'll write A equals to sine inverse in brackets 34 times sine 80 divided by 38.5. Good, so calculator will help us here. I'll work out the bracket first. The answer that I have, then I will sine inverse it. Or if you want, you can enter it just as it is here on the calculator. Remember, different calculator work differently, right? So you'll see how your calculator works. Times sine 80